Hello, my name is Stephen Ramage, and I work for an organisation called the Group on Earth Observations, or GEO for short. We work with more than 100 countries to help monitor the pulse of our planet. Our work helps governments to learn about and share science and technology. This supports the development of policy and aids decisions, for example, relating to climate action, the reduction of disasters, and sustainable development. By sustainable development, we mean addressing some of the key goals set by the United Nations to help lift people out of poverty, ensure they have access to food, to assess what water is available, where and when and to whom, as well as generally assessing the health of our planet. All of this is done through Earth observation and related activities. Earth observation is the gathering of information about planet Earth's physical, chemical, and biological systems. These are referred to as remote sensing technologies and typically relate to satellites carrying imaging devices. However, we also need to check what is happening closer to the ground. We call this in situ monitoring. These sensors could be for soil moisture, groundwater, ocean salinity, and many other measurements. Earth observation is used to record and measure historical and current conditions, including recent changes in the natural environment and the built environment. This is important when we want to see the impact of humans on our changing planet. These technologies, which are usually described as sensors, help us to monitor changes on land, sea, and air. Here we can see how satellite imagery can show change over time and its impact. This is courtesy of NASA images of change. The first image highlights the shrinking Arctic sea ice over a period of 32 years. We have been losing Arctic sea ice at an alarming rate over the decades. However, what happens in the Arctic does not stay in the Arctic. Sea ice loss has far-reaching effects around the world. We all know how global impacts work, unfortunately, due to the ongoing COVID pandemic. One critical aspect is the role that snow and ice play by reflecting heat and balancing other parts of the world that absorb heat. Less ice means less reflected heat, meaning more intense heat waves worldwide. It can also mean more extreme winters if we look at something called the polar jet stream, a high pressure wind that circles the Arctic Ocean. If it's disrupted by warmer air, it can travel to other areas, bringing colder air with it. Additionally, rising seas bring danger to coastal cities and small island nations by making coastal flooding and storm surges worse. These extreme weather situations are already causing damage to crops and therefore changing food prices and adding pressure for vulnerable communities, such as Indigenous people. This also obviously has an effect on animals that live in these regions. For example, reindeer, walruses, and polar bears. They need to adapt or die. This is also forcing some animals to get closer to humans as they seek food, which brings possibilities for dangerous exchanges on both sides. The second image highlights the growth of human settlements over a 25-year period. Sometimes described as urban sprawl, this growth can have many negative consequences for people living there, as well as for the environment. Many people are moving to cities because of poor education or employment possibilities. With increasingly more people comes greater energy use and vehicle use, which leads to greater air pollution with a significant impact on health. These emissions also include gases that contribute to climate change. There are impacts on agriculture capacity, increased runoff into rivers and lakes, loss of natural habitats, wildlife, and open space. In its path, urban sprawl consumes vast acres of forests, farmland, woodlands, and wetlands, really impacting biodiversity. Other harmful effects on human health lead to higher rates of obesity, high blood pressure, hypertension, and chronic diseases. Urbanization can also introduce overcrowded living conditions, putting added pressure on food systems, insufficient water availability, waste disposal problems, and sometimes lead to crime and other consequences of social deprivation. The third image is the most obvious in terms of seeing the change over time and noting the implications of drought taking place over a much shorter 3-year period. Drought has an obvious and immediate impact on society via economic losses, whether that is via reduced income for businesses reliant on the water source, such as fishing or associated leisure activities, or for those who live around the water source, Water is essential for so many day-to-day activities that it can also cause conflict when there's not enough water available. Diminished and late rainfall combined with long-term increases in temperatures can jeopardize food availability. For example, the depletion of fish stocks and energy supplies for people in the region. It can be extremely difficult to grow staple crops, and livestock farmers can suffer losses forced by shortages of water and feed. Drought conditions can also provide substantial increase in wildfire risk. The meteorological drivers of drought often cause subsequent effects such as reduced catchment runoff, river flows, and lake levels, all of which can be regularly monitored by using Earth observations. These are just 3 examples where the differences are immediately obvious. There are many other use cases such as flooding, deforestation, snowmelt, all of which have a massive environmental and social impact, as explained. There are now scores of activities underway with respect to COVID and how Earth observations can provide inputs. For example, Copernicus is the European Union's Earth observation programme. It is coordinated and managed by the European Commission in partnership with the European Space Agency, member states, and other agencies. The Copernicus Atmosphere Monitoring Service, CAMS, which monitors atmospheric conditions throughout the world, provides updated air quality information on a daily and weekly basis. When combined with the European Centre for Medium Range Weather Forecast Analysis and Models, it provides fresh data for users every day. To help monitor the effects of the pandemic, CAMS tailors this information specifically for COVID-19, providing visualizations, including maps, along with animations of the gases that impact air pollution for 50 major European cities. The Copernicus Climate Change Service, C3S, has developed an application that allows health authorities and epidemiology centres to explore whether temperature and humidity have any effect on the spread of the virus. In 2019, GEO created the Indigenous Alliance. This is working with underrepresented and sometimes marginalized communities who live in important and often very large areas of land, including forests and coastal regions. The GEO Indigenous Alliance is working on key activities which are linked to some of the areas I've mentioned previously. For example, climate action and reduction of disaster risk. Numerous activities are underway to bring together the traditional knowledge with state-of-the-art technologies such as Earth observations to support the work of Indigenous communities. GEO has also been running programs with a number of global technology organizations, including Amazon Web Services, Microsoft and their new planetary computer, and here you can see Google Earth Engine. The goal has been to work with least developed countries to help them make use of the generous support provided by these companies, to learn about Earth observations technology, and to work with all the openly and freely available data from providers around the world. GEO is now focused on working more closely with small, medium, and micro-sized companies internationally. Here is an infographic that describes the work of GEO. If you'd like to learn more about our daily activities around the globe, you can contact us via Facebook, LinkedIn, Twitter, or via our website, earthobservations.org. So we work globally to help countries understand the value and usefulness of open Earth observations data and information. This is done by aligning work on science and technology with policy development and decision-making. Our goal is to help countries deal with national priorities while supporting global issues through Earth observations. We describe this as Earth observation for the benefit of humankind. I'd like to thank you for your attention, and I hope that provided some insights into the different application areas for Earth observations, as well as the work of GEO. Thanks again.